Alright guys, welcome back. Thanks for watching my earlier videos. I'm still working out how I'm going to put them all together, but I'm going to call this video at the start. This is about the periodic table now. Okay, I know my other videos had a little bit of that in it, but what we're going to do now is we're going to talk about specifically about the periodic table, right? Because we now know a little bit about how atoms work. We've done a bit of revision on that. We know that an atom is made of, if you don't know this, go back and watch the previous videos, protons and neutrons in the middle of a nucleus. Electrons are around the outside in shells, and those electrons and where they sit, they can fit a certain number of electrons in each shell, and where those electrons sit, that's called their electron configuration. And that electron configuration is going to be really important for this video. So you have to understand what I mean by electron configuration. Alright, so go back and watch the previous videos if you haven't already. But if you have, you should know how to write those. Okay, so lithium's electron configuration, lithium has an atomic number of three protons in the nucleus. That means it has to have 3 electrons if it's neutral, and those electrons have to go 2 into the first shell, 1 into the second shell, so its electron configuration is 2, 1. I've written that backwards for you guys, but you're smart enough to work it out. So you need to be able to do that because the electron configuration thing is going to help us understand this periodic table later on. But now we're going to talk a little bit about this more in detail. Where did this thing, the periodic table, where did that come from? Okay, I'll try and get out of the way here. Where did this come from? It looks like it's organised, right? It doesn't look like somebody's just grabbed paint out, right, on the computer and gone, oh, I'm just going to make up some letters and do some colouring. It doesn't look like that. It looks like it's fairly official. It looks like it's been thought about. It looks like it's been organised. And you know what? It has, all right? This little bad boy here, right? This picture, this graph, oh, not this graph, but this table, this periodic table, why is it called a periodic table? I don't know. Work that out. This table has been painstakingly designed, all right, over the last 200-300 years, and it's been refined and it's been twisted and changed, and it's awesome. You can write books and books and books on this stuff. You know how they say pictures are worth 1,000 words, or this picture's worth 1,000,000 words, right? There is so much information just in this table. And if you can unpack just a little bit about how it works this term and help yourself understand it, you will, man, awesome. It's really cool. No one doesn't want to know stuff, right? So challenge yourself. Let's see if we can understand how this periodic table works. Because remember, this periodic table includes every single what we call element that is really like the building blocks of matter. All right? So these elements help us to understand how the world works and why they do what they do. And why, we're coming back to our question, is why does sodium explode when you throw it into water? So periodic table, really, really important that we understand how it works and how it's organised. Not just some dot points on the rules, but actually where did it come from? All right? So to tell you about it, I want to bring up this guy. This guy is one of my heroes. I think this guy's awesome. He looks like a scientist, right? Or he looks like a bushman or something, like Ned Kelly or something. But he looks awesome, all right? Cool hair, big beard. He's the man, all right? His name's Mendeleev, right? He's an awesome guy. He was Russian, I believe. I hate putting things on video, but I believe he's Russian. He had a few things he loved to do. He loved playing, apparently, solitaire, like a card game. He loved his vodka. And he loved science, right? He loved investigating things. And what this guy did, he's the father of this modern periodic table, right? So what he did was he did science to his world around him. That's what he did. He looked at all the things that he could touch, he could smell, he could see, and he played with it. He did experiments. He organised things. He essentially went around he went within his space and he tried to organise all of these elements into some sort of logical order. Now remember, he's doing this, I think it's about 200 years ago, and he's doing this in a time when we don't know a lot of what we have now. You take for granted you've got these textbooks that tell you all about these elements, these atoms and their structure, but he had no idea. He didn't know about electrons. He didn't know about electron configurations. You guys should know more than Mendeleev did at this point, but he knew how to do science, all right? He knew how to experiment, to control variables, to take records, to repeat experiments, and what he did was he did that to as many elements as he possibly could. And he then took those results and organised them into the table that we see. And the way that he did that, I'm going to go back to the periodic table. The way that he did that was he took the elements and he organised them in 2 ways. He organised them into things, these rows, okay, from left to right, called periods. They call them periods. So left to right is called periods. So we've got period 1, period 2, period 3, 4, 5, 6, and 7. Okay, so that's 7 periods. He organised them that way, horizontally, by their mass. Okay, how much they weighed. So he put hydrogen, the lightest element, up the top, and then he went to helium, which is the next lightest, and then lithium, beryllium, boron, and all the way down to the bottom of the periodic table. So as you go down along these periods, the elements get heavier and heavier. That's because they've got more protons and more neutrons in their nucleus, and they have more electrons as well. So he organised them that way into periods based on their mass. He also then took them, instead of just having, if you did that though, and you just lined them all up, you know, like at a police lineup, right? You're going to have a really long list. You got like 118, 19, like crazy number of elements all in one row, and it doesn't tell you much apart from the fact that you're the lightest and you're the heaviest. Just like if I could line you up shortest to tallest. That's essentially what he did. We want some more information stored in this table. So he thought to himself, what if I organise them not just into vertical periods, but into, not in horizontal periods, vertical rows. All right, so he organised them into rows, and those rows are called groups. So this period, this group is called group 1. It's yellow. Group 2 is, in this case, orange. And we've got group 3, 4, 5, these blue ones. Okay, they're called the transition metals. We're not going to focus too much on those. We're going to jump across to group 13, or sometimes we say group 3 because we skip the middle. Group 4 or 14, 15, 16, 17 and 18, the purple ones at the end, the noble gases, the ones that stick their noses up at everybody. He organised them into groups. So he lined them up, lightest to heaviest, and then he said, all right, you guys come together. Now he didn't, how did he do that? Why did he put all of these guys into a group? Lithium, sodium, potassium, rubidium, cesium, francium. Hydrogen's a bit of a funny one. How did he do it? Like, if I lined all of you up, shortest to tallest in a classroom, how would I then go and, how else could I separate you? All right? He thought that to himself, and he thought, how can I separate these elements to make sense of what they're doing? He did it through experimentation, and what he did was he said, okay, I'm going to organise elements into groups, vertical columns, based on their reactivity, their chemical properties, their physical properties. Are they solids, liquids, gases at certain temperatures? Do they react? How do they react? Do they react similar? So for example, he put all of these guys, we call this group, group 1, the alkyl metals. Okay, and he put them into one group because, well, they're really reactive. They're metals, and we'll talk about what that means. They're metals, but they're really reactive, right? They're super reactive. For example, all of these guys will explode in water. Not just sodium, we've picked sodium because we have access to that, but all of these guys will explode in water, and they actually get more violent as you go down. They get bigger and bigger, right? The explosion, they become more reactive. So he put them all in a group. These purple guys over here, royalty, right? Royalty, they're the noble gases. These guys, he put them all together because they're the opposite to the alkyl metals. They're super unreactive. And if they're unreactive, he put them all together. So not only did he think about their masses, but he thought about their chemical and physical properties. So these guys don't react with anyone. They don't even react with themselves. And when I say react, I mean bond, transfer electrons, stick together, right? These guys are all monoatomic. Mono meaning one atom, monoatomic. They do nothing, right? They're actually used in neon lighting. Like when you zap them with electricity, they go different colours, which is pretty. But they don't do much else. They're noble gases. And all of these groups, he put them together based on their physical and chemical properties. So all of the blue ones here, the halogens, they all do the same thing. They bond the same way. They form the same molecules, all right? So do these guys roughly as well. So the transition metals do similar things all in here together. But and these are the orange ones, are the alkaline earth metals. They also react similar as well. They form similar molecules. So he put them together and organised them like that without knowing much about their structure at an atomic level. He didn't know about electrons. He didn't really grasp how they were all lined up, and he did this. And he was so confident, right? This is where I say chemistry is cool. This is his periodic table. He was so confident in his method of organising these things. Maybe he had a bit of vodka, I don't know, but he was so confident that there was actually, see these white ones? I don't know if you can see it well on the screen, but there's 4 or 5 white elements here that were undiscovered when Mendeleev did this. Like, they didn't know about them yet, all right? That's only like 200 years ago. Didn't know about them. He was so confident with the way he was organising his groups that he left blanks. That is cool. Like, he was looking into the future, and he's going, he told these scientists, he said, look guys, I don't think zinc and arsenic are very similar and they're not going to fit in these groups. I think you're going to find other elements later down the track that are going to fit into these boxes. I'm going to leave them blank. Man, that gives me tingles, right? Like, think about that. That is so cool to predict that there are elements that we haven't discovered yet. And you know what? We did find them. And let me have a look here. We did find them, and they... He did find them, and he was able, not even did he just predict where they would be in the periodic table, so gallium and germanium were two of the big ones. He actually predicted their properties, like how much their density, their melting point, when they melt, when their boiling points. He predicted their colour, he predicted the molecules they would form, and he was spot on, like ridiculous. So he didn't even know they existed. He predicted they would exist, and that they would have certain properties. This guy was awesome. He is the main man, right? Mendeleev. So just so you know, that's how he organised the periodic table. All right, I'm going to pause it there.